Alright, see what we have. Alright, jump game part 3. I previously solved this. Medium. Given an array of non-negative integers array, you're initially positioned at the start of the index. You're initially positioned at the start index of the array. When you're index I, you can jump to I plus array I or I minus array I. Okay, so use the value to modify where you position, left or right. Check if you can reach any index with it at value 0. Notice you cannot jump outside of the array at any time. So you're initially positioned at start index. So start index 5, 0, 1, 2, 3, 4, 5. So that means 0, 1, 2, 3. Yeah, so you can either move 1 here or 1 here. Guess you probably move. I guess if you go here, then you just move 2 here. So move to 3, 3 moves 1, 2, 3, and then 2 moves 2 over to get to 0. Yeah. Start index here is index 0. So you have to move 4, 1, 2, 3, 4. And then this one you can only move 3 this way. So 1, 2, 3. And then move 2 this way. Okay, and just return true if it reaches it. Okay, this seems like a simple kind of process queue. Seems like a simple process queue. It would probably take O of n turns at most. So the process queue will be, let's say, I need to have maybe a visited or seen, which is going to be false for every index in the array, where n is the length of the array, and I want to have just a process queue. Does it need to be a queue or can it be a stack? Don't know that matters. I'm going to go ahead and just use a queue. So double-ended queue. Make it initially. I guess this probably should be initially the start value. Process queue of next index of indices to kind of visit. And then while there is something in the process queue, I'm going to do some stuff, otherwise return false. And let's go ahead and take the top. Let's call it spot from the queue. Pop left. Is it pop capital L left or lowercase l? I think it's capital L. Let's say Python double-ended queue pop left. Is it lowercase or capital? It's lowercase. Okay. And then it's gonna look at the positions to left and right. So I guess I should do if. I guess delta is going to be the difference from this thing to the next position, which is whatever the value is at this spot. If actually, let me double check one thing. What is, okay, the values in the array can be at most the array length. I'm actually going to do something where I'm going to go ahead and hack it and say this is going to be times 2n times 2n. This is just going to allow me to kind of ignore bounds when I do this indexing, because it'll just wrap around or find a position that has false. Actually, I think I need to also change. I need to say the first spot is visited, so visited at the start index is true. So I guess maybe that means I need to put the other stuff to be true already. The other visited spots to be true. How do I want to do this? Okay, maybe this hack is not going to be worth it then, because I don't know a quick way to. I guess I could do a list comprehension here, so it'd be false, true for k in range 2 times n if now how do I want to do this? This is going to be k less than n. I just want the first half to be false and the second half to be true. I guess it should be the other way around, k less greater than equal to n. I need to double check if this actually works. Visited. Does this work? Okay. Right, looks like, so this should be 6, 7 false. 1, 2, 3, 4, 5, 6, 7 false. And then 7 trues. Okay, yeah. Okay. Alright, so spot. So that'll allow me to do this next part without having to worry about indexing. So if array, I guess it'd be visited at spot plus, I need to still get delta. Delta equals array at spot minus delta. I guess if it's not visited. Then visited at a spot minus delta is true. And then I guess, whoops, I forgot the escape case. If this value is 0, then return true. Okay, so if I haven't visited the leftward spot, then say that I visited and add that to the queue. And then similarly for the right spot, if visited at spot plus delta, if not visited. then visit it and add that to queue. And I think that's it. Okay. Sure. Is there a faster way of doing this? I think a queue versus a stack would probably be similar. Is there a smarter way? Smarter way of finding whether or not there exists a path? I guess you could go forwards and backwards, kind of traversal, forwards to find from the starting point your kind of set of indices that branch from it, and then how would you do backwards? Given your ending indices, I guess you can't really do backwards traversal of the kind of possibility graph in this one, because you can't. Any index could be the one that jumps to the last node in the graph, or one of the last nodes in the graph, where the last nodes are the indices with 0 value. Okay, well, it is what it is. Alright, summary. This is a fairly straightforward use of a queue along with a set or some tracker of visited node state kind of indices. So initialize tracking to all false, so like unseen everywhere, and then put the first kind of state or the starting point into the queue, and use a loop to process the top of the queue. When have end condition check, i.e. if the value at that position is equal to 0, return true. And then otherwise add unseen left and right, kind of left and right positions from that state, from that current position to queue. So yeah, this initialization, there's a small hack here to make it not have to check for out of bounds. But initially it's just basically all false. The starting state has been visited, so it's true. Starting index of your process queue. Take the current index from the queue. Take the value at that spot in the array. If that value is 0, this is the end condition. Otherwise, move left and move right if possible. Move left if you haven't seen the spot leftwards. Add it to the queue. Similarly, move right. And then otherwise, if there's nothing to process, then basically you get stuck. Time complexity is going to be O of n, where n is the length of the array, as in the worst case. You'll need to traverse every position before determining that 0 exists or not. Like 0 could be the very last position that you traverse at the very end of the array, something like that. Base complexity is going to be O of, actually this is going to be O of n, isn't it? O of n. Since the queue is processing with kind of branching factor, I guess in theory a stack would have been more space efficient. I think maybe a stack would have just been O of 1, no, stack would be like O of log n. I believe it would be O of log n. Since you're just going to put like 2 things left and right onto the stack. Yeah, it's kind of like a depth first search. Yeah.